ESB architecture. Here you can see a Mule ESB architecture. The Mule plays a special role as it is not a full JBI implementation, but only provides external JBI connectors, which can be used to integrate with other JBI environments like service mix. It is also not a typical ESB as is often stated. For example, in because it does not provide common messaging backbone as an associated back-end services, but more of a freely combinable mediation layer where components are not plugged in but stick together as needed. This is seen as an advantage over traditional ESB, stating one difference between Mule and traditional ESB is that Mule only converts data as needed. With typical ESB, you have to create an adapter for every application you connect to the bus and convert application data into single common messaging format. Mule increases the performance and reduces the development time over traditional ESB. As a result, Mule uses a proprietary API and message format and does not embrace JBI or SCA as its underlying integration model. Service components, previously called Universal Mule Objects or UMO, implements custom application logic can operate on the content of the message on a logical level. Similar to JBI service engines, they are decoupled from specific messaging or protocol formats required for communicating with other components or external applications. This is performed by transformers, which converts between different data formats and wrap them in Mule messages, whereas the transport handle protocol conversions as needed, bridging between communication protocols such as JMS, SOAP, HTTP file or proprietary protocol similar to JBI binding components. Finally, routers are used to deliver incoming messages to service component and for sending outgoing messages to the target component according to the configuration. In JBI, there is a central shared router that handles messaging the messaging and connection in all endpoints. The normalized message router routers can perform additional logic such as filtering or message composition or decomposition, implementing a message routing patterns. The basic architecture and message flow is illustrated in this figure here. Mule uses a compact XML format for describing the configuration and these are the inbound and outbound routers. The Mule uses XML-based XML format for describing the configuration and supports the Spring for lightweight specification of the desired integration. Development support is provided by the Ant and Maven scripts. There is an also Eclipse plugin, Mule IDE, for basic configuration and deployment from which within the IDE. Recently, the Mule IDE has been extended to provide visual editor for designing integration maps, but this has not yet been ported to the Mule, the new Mule 2.0 release. Compared to the full JBI solution, Mule is easier to get started with the and provides a more lightweight configuration-centric integration model with little restrictions on architecture or message format. Components may have be simple Java object or Spring Beans, which can be directly integrated without code changes by writing suitable configuration. This simple approach allows the quickly set up the prototypes and reduce the time to market or for small to medium size projects, but allows solution to grow enterprise scale when needed. Because of the clustering support in Mule, especially in the small or performance critical settings, Mule provides an advantage by transforming messages only when it is needed at the last possible moment, which is sometimes compared to late binding in programming languages. Mule has recently been integrated into an integration stack with various components working together called Mule Gateway. Integration into existing environments is possible in several ways, either as a component inside JWA application server or by connecting to an existing message bus over JMS or similar protocol supported by Mule. The deviation from Open API's common messaging format and core ESB principles also has significant disadvantages and bears the danger of vendor lock-in. Mule is the only implementation available, and spaghetti integration as components are still tightly coupled and statically configured, which can result in high complex and transport. In this way, Mule really only realizes component integration and not service-oriented integration, which would require the consistent usage of standard-based interfaces such as WSDL, which is utilized in JBI. Also, because the endpoint have to explicitly specify, there is no real location transparency, which is the core principle behind SOA. Moreover, Mule does not support hot deployment or reconfiguration on the fly. This has been the long-standing point of criticism and will be addressed in upcoming version by using OSGI as underlying component model. Much of the Mule's unique advantages proclaimed in Mule's advantages are there and can be realized with JBI in the standard compliant manner without incurring disadvantage of Mule, as shown here. Any component type is supported in JBI. Components can be easily wrapped into service engineer or engines or binding components. Service mix also support POJO, plain old Java objects, directly through API extensions and provide lightweight configuration model using Xbeans. JBI 2.0 will also support OSGI components. Better component reuse and less API overhead. JBI components can be reused across different runtimes, which is out of scope for Mule. This comes at the price of the added API complexity, which is why the many JBI implementation introduce more lightweight API layers that allow easy development of JBI component, but are not always fully JBI compatible, restricting use across JBI containers. JBI 2.0 will, however, refactor the API. It is overly complex or restrictive and make the specification more developer friendly in general. Recording is also not necessarily in JBI, as service units provide rich ways of reconfiguration even at runtime. No restriction on the message format. JBI requires transformation into normalized but non-canonical XML format on the purpose, and its distributed complexity of the integration solution minimizes the risk at tight coupling and point-to-point integration, which can easily happen at the Mule implementation. Are free to optimize flow where possible, so transformation is not performed when the communication endpoints use the same protocol. Also, binary formats and proprietary extensions are supported all through attachment and metadata respectively. Support for various topologies beside ESB. The JBI specification does not restrict implementation to an ESB topology, but allows the implementation to choose any topology that makes sense in the target environment, which has been already shown target environment. And next version of OpenESB will support peer-to-peer messaging using JXTA, and other JBI implementations support various messaging and clustering forms such as JMS, SEDA, and proxying. The disadvantages identified above and restriction imposed by the proprietary Mule API make it unusable for sustainable tool integration, especially when comparing against the requirement and alternatives outlined before. Also, Mule 1.x has been previously tried for the toolnet redesign in a case study, but was found to be too restrictive with regards to endpoint addresses, as it did not support dynamic endpoint. For example, when tools come online or go offline, this limitation to static configuration impedes dynamic tool reconfiguration and agile workflows. Mule does not fully apply best practices in SOI and enterprise integration, which may result in complex solutions that are easy to build initially but hard to maintain later. However, this straightforward approach to integration, easy configuration, maximizing reuse of existing service component, and low API overhead, maximizing performance and ease in development, they are the key advantages that should be allowed in JBI 2.0 where possible. Here here you can see message sent to http :// here myfirm.com/mule, and it's interacts with the HTTP message here, and it's connected to HTTP transport, and HTTP transport is connected to the service here. Here you can see the inbound router, and here the endpoint http :/ myfirm.com/mule is there, and here the outbound route is connected to the endpoint JMS :/ myqueue. Here the customer data service component, data service component, and endpoints are in the service here, and here the service is connected to JMS transport, and the transport is connected to JMS message here, and it's connected to service here. Here you can see the inbound router and endpoint JMS :/ myqueue, and here the order fulfillment service component, and this endpoint are in the service here. Now this is the end of my presentation. Thank you very much for watching it.